Welcome back. Here we are. This is page 4 of Unit 4, Section 2, and we're talking about quadratics and we're talking about factoring. So this page, we're talking about special cases. So we have this thing called the difference of two squares. And that's kind of pretty simple to identify, but if you can't, just bear with me here. So notice that here we have two binomials, and you can do FOIL or you can do the box. I'm just going to do the box because it looks pretty on the video, but you can do FOIL on your own. So I'm going to multiply ax, and then I have minus b here, ax, and then I have plus b here. So when you multiply these guys, you have a squared, x squared. Multiply, you have negative abx, multiply positive abx, multiply negative b squared. At this point, when you combine like terms, we are going to combine abx with abx. So you add them up, you have 0 abx, right? So then you have a squared, x squared, that one, this is 0, and then I have minus b squared. All this to say, you can go back and forth between these guys. But the trick here is to be able to identify a perfect square here, a perfect square there, and a difference between the two perfect squares. You could have a number here that is a perfect square with the variable squared. You could have another number here that is a perfect square with the variable squared. And then when we get to the examples, it's going to make more sense. So another one that I would like to do the box here, or if you want to do FOIL, do FOIL. Now we have 3 terms, or a trinomial right there, multiplied by a binomial, 2 terms here. So x negative y here, x squared, xy, y squared. Okay, multiply, I get x cubed. Multiply, I get x squared y. Multiply, x y squared. Multiply again, negative x squared y. Multiply, negative x y squared. Multiply, negative y cubed. And just like what we did in the previous one, we're going to combine like terms. This is like this. And then I also have this is like this. So when you combine like terms, or when you add like terms, then these guys will add up to 0. These guys will add up to 0, leaving you with only x cubed minus y cubed. And that could be any perfect cube. 125, 64, 8, and you name it. As long as they're both perfect cubes and you have a difference between them, then you're going to use this formula right here. And same thing is true for this formula, but when we have a plus between them, or sum of perfect cubes. So we're going to do the same thing we just did, but now with a plus here instead of a minus. Okay, multiply. I'm just going to go a little faster on this one because you already know how to multiply. And same idea, we will combine like terms. And these two add up to 0. These two add up to 0. Leaving us with only x cubed plus y cubed. Notice that we have a sum of 2 perfect cubes. When you have a sum of 2 perfect cubes, you're going to use this formula. When you have a difference between 2 perfect cubes, you're going to use this formula. This is what it's going to look like when you have numbers, which I think it makes more sense. So 9x squared is a perfect square. 25 is a perfect square. And then you have a minus between them. Oh, well, so I have a difference of two perfect squares. So square root, and one is plus, one is minus. That's simple. Same idea here. They're both perfect squares. You take the square root, and one is positive, and one is negative. Oh, got crazy there. Okay, now 8 is a perfect cube. 27 is a perfect cube. And I know that because when I cube root 8, I get 2. When I cube root 27, I get 3. Because 3 times 3 is 9, times 3 is 27. Okay, so now there's a difference there. So I'm going to use this formula right here for the difference of two perfect cubes. So cube root minus cube root. Then I'm going to follow there. You square the first one, which is 2p. That will give you 4p squared. And then you add, you multiply them. So 2 times 3p is 6p. I mean, 2p times 3, you get it. Plus the square of the second one. And that's all you can do. Now we have the sum of two perfect cubes. I'm going to follow this formula right here. So cube root, and then you're going to square the first, minus, multiply, and then you're going to square the second one. And that's pretty much all you need to do on this page. So now, when you're trying to factor, and there's absolutely nothing you can do to that trinomial to come up with the two factors, that's what we call prime. Just like you have prime numbers, you also have the prime trinomials. Okay, so if I'm going to try to factor this, I have to look for the two numbers or the two factors that multiply to 5. Well, 1 times 5 equals 5. But you know, when I'm trying to find the two factors that add up to 5, I only have 2 plus 3 that make 5, and 1 plus 4 make 5, not 1 plus 5. 1 plus 5 doesn't make 5. So I cannot, when a quadratic expression cannot be factored, then it's called prime. Okay, but you still need to try. So like this one, I'm going to try. So negative 6 goes there, 6 goes here, and I'm looking for two numbers that multiply to negative 6, and same two numbers that add up to 6. Well, there's nothing, so I cannot factor this. Therefore, this one is prime. So now this is a quick little review from the previous pages. I need to multiply. So I get negative 30 right here, because 2 times negative 15 is negative 30, and I'm looking for the two factors of negative 30 that add up to negative 7. Well, 3, negative 10, multiplied to negative 30, and 3 minus 10 add up to 7. And because the leading coefficient is 2, I need to go back and divide by 2, simplify the fraction, and then if I can simplify, I have to bring the denominator back up. And then lastly, I need to go ahead and write the factors. So 2 goes back up to the top, so 2x plus 3. And then here I was able to simplify, so x minus 5. Now the second one I have, I need to find two numbers that multiply to negative 12, and same two numbers that add up to negative 4. Well, I can do this mentally, but if you want to do that, you can. So negative 12, and then I have negative 4 right there. So, well, 2 times negative 6 will give me, when you multiply, will give me negative 12. And then when you add them up, you get negative 4. Perfect. So the leading coefficient is 1. I don't have to divide. So x plus 2. and then x minus 6. Let's do one more. So before I start any factoring, I always have to look for the greatest common factor. The previous three, they just didn't have one, okay? But when you look, you're like, okay, I can divide everybody by 2. So greatest common factor here will be 2. The greatest common factor, the GCF, goes in the front, and then that means you're dividing each one of those terms by the GCF. So 2x squared divided by 2 is x squared. 16x divided by 2 is 8x. 24 divided by 2 is 12. So then we would have to try to keep going. Well, I'm looking for 2 numbers that multiply to negative 12 and same 2 numbers that add up to 8. Well, there's nothing that multiplies to negative 12 and add up to 8. So I cannot factor any further. So this will be my final answer for that one. And then I'll come back and finish this page up.